Hey all, my name is Firas, and this is the first video in algorithms as an introduction, and there will be more such videos to help computer science students understand the subject and solve related problems. Let's start! Let's start with an introduction and with the first question, what is an algorithm? An algorithm is a step-by-step procedure that provides a solution to a computational problem. You can also imagine it as a function with 0 or more inputs, and it should generate at least one output. Otherwise, there is no use of writing an algorithm, so it must generate some results. Before you design an algorithm, you have to master a bunch of techniques for analyzing algorithms. Algorithms should have some properties such as correctness, security, user-friendliness, modularity, maintainability, and simplicity. The most important feature of algorithms is its efficiency or performance. And for analyzing the performance of an algorithm, there are two main measures: time and space complexity. Those determine how many resources are needed on a machine to process an algorithm. Where time measures how long it takes to process the algorithm, space measures how much memory is used. So all these things are important, but we need to focus on the performance. Then maybe you ask, why do we study algorithms and performance if it's at the bottom of the heap? Would people rather have performance or more user-friendliness? Why do we care then? Well, sometimes performance is correlated with user-friendliness, so it measures the line between the feasible and infeasible. For example, when there are real-time requirements, if it's not fast enough, it's simply not functional, or if it uses too much memory, it's simply not gonna work for you. One more thing, performance is like money. It's like currency, like you have $100 and you use it to pay or buy food or whatever that is more important for you than money. Well, similarly, performance is what you use to pay for user-friendliness, what you pay for security. And some people will prefer to have more functionality, so some people program in Java, even though it's much slower than C. Maybe it costs in terms of performance to program in Java, but Java is worth it because it gets all these object-oriented features and so forth. So that's why you need performance. It's a universal thing that you quantify and use to pay for those other things you want. Let's start with a simple problem, which is one of the oldest problems that has been studied in algorithms. It's the problem of sorting. The following problem does that, which is called insertion sort. This is written here in pseudocode. Now let's try to figure out a little bit what this does. It basically takes an array A with n elements. There is an invariant that is being maintained by the for loop, which is the key element. And the goal is to go through the loop, pull out the key element, compare it to items on its left side, then insert it in the correct position in the array. In this way, the length of the sorted part will be increasing each time. That's why it's called insertion sort. Let's begin and see what it means. We have the following array with size 6. Of course, the first element has no neighbor elements on its left side, so we mark it as sorted and move on directly to element 2. We compare 2 with 8. We see that 2 is less than 8, so we swap it with 8, and now the first two elements are sorted. Next, we have 4. This needs to be after 2, so we swap it again with 8. Now the 9 is greater than 8, so we leave it in its place. And so on, until we have the array sorted. Now, if I want to analyze the running time of this algorithm, we can see that it depends on a lot of things. First of all, it depends on the input size. So an array with 9 elements will definitely take longer time to be sorted. So we need to parameterize things in the input size, the time as a function of the size of the array we are sorting, mainly T of n. It also depends on the state of the input. If it's already sorted, this would be the best case, or the worst case if it's reverse sorted. So here we can differentiate between those three cases of analysis. In the worst case analysis, we calculate the upper bound on the running time of the algorithm. We must know the case that causes a maximum number of operations to be executed. In the best case analysis, we calculate the lower bound on the running time of an algorithm. We must know the case that causes a minimum number of operations to be executed. In average case analysis, we take all possible inputs and calculate the computing time for all of the inputs, sum all the calculated values, and divide the sum by the total number of inputs. We must know or predict the distribution of cases. Analyzing the performance of an algorithm should be machine independent. So if we are analyzing the running time and we want to find out the worst case, we have a relative speed if the algorithm will be running on the same machine, and we have the absolute speed if the algorithm will be running on a different machine. So this makes it difficult to analyze an algorithm. That's why this should be machine independent. And here comes the asymptotic notation in charge. But this will be explained in the next video, so stay tuned.